Hi everyone, this is Maths World UK. I'm James Grime and today I'm speaking with Ben Sparks. Ben has brought in a mathematical magic trick for us to try. It's a good one. So first, Ben's going to show you how to perform the trick, and then of course you're welcome to try and work it out for yourselves. But then Ben will describe the maths behind the trick as well. And this is what Ben does. He was a teacher first, but now he travels around and gives fun and inspiring mathematical talks. So I started our conversation by asking Ben what counts as an inspiring bit of maths.
Something that surprises me is a good sign. And that's interesting because to be surprised about a bit of maths, you have to have a little bit of mathematical intuition about what you expect to happen anyway. And if something happens which is unexpected, if you didn't know what was expected to happen, then you're not surprised by it. And perhaps actually one of the things I wanted to show you is a good example of that. There's a certain level of mathematical awareness you need for it to be at all impressive, and without that it's not impressive, and if you've seen it all before it's not impressive. So there's a sweet spot of awareness where it sort of works as a trick. But for that reason I quite like doing maths in the format of a magic trick. It has that flavor of performance which I enjoy, and as a teacher I know what the effect of a surprise will do to your motivation to learn something. So if you see something which you're like, whoa, I didn't expect that, suddenly a lot of the fuel of the difficult job of doing maths and investigating things is provided.
You're going to surprise us with your mathematical magic. So what have you brought in to show us?
This trick involves memorizing a book, and so I found a book by a friend of ours called Matt Parker, called Things to Make and Do.
Not ringing any bells.
Anyway, I've memorized this book. It is a good book and it's got some nice maths in it. So to prove I've memorized that, I need you to take it away from me so I can't look at it anymore. Is that okay? Can you?
Yeah. Okay. Well, how can I do that though?
Have you got the Zoom delivery service installed?
Yes, I have.
You have. Well, then use that.
Okay.
I'll just pass it over.
All right.
I'll just pass it over like this.
Got it.
Good. I'm glad that worked. What I'm going to do is I'm just going to switch my screen to have a little blackboard. So you should be able to see a little thumbnail of me. Hi, but I can also write on this. Can you give me a 3-digit number, James, please?
I'm going to give you a 3-digit number. Okay. I'm going to pick 852.
852. Are you happy with your 3-digit number? You can change it if you wish. But...
Yeah, I am happy with my 3-digit number.
So all I'm going to do is ask you to reverse that number and then subtract, and then actually we're just going to get a page number which I'll tell you what's on the page, and that's the sort of proof I've memorized it. But can you reverse that number for me? So write it backwards.
258.
Yeah. Okay. And can you do the subtraction of those two? You can talk me through it if you like. Or he's working on paper. I can see the mathematical gears going. I'm very curious about how you're doing this. What are you crossing things out, or are you estimating this?
Well, okay. This is how I was taught at school. I need to subtract 8, but I've not got enough, so I cross out the 5, it becomes a 4, the 2 becomes a 12.
Do you write that 1 up there like I've just done?
Yes, exactly like that. And now I've got 4 when I subtract. Okay. And then I go into the next column. I need to subtract 5, but I've not got enough because I've got a 4. Yep. So I cross off the 8, it now becomes a 7, and I've got 14. And so now I subtract, which is 9, and then I've got a 7. I need to subtract 2, and that's fine. That's a 5. 594.
Good. Mental arithmetic on paper is still alive. Actually, what's interesting is that everybody does this slightly differently. There's loads of different methods for doing this, and there's a nice discussion to have. What I like about this is there's a good way of checking whether you think you might be right. The algorithm is very familiar to me, what you did. I think we were probably taught in the same generation and have that sort of drilled into us. But 850 something, take 250 something, I'm pretty sure is approximately 600, which is why I kind of believe the 594 is sensible. Okay, next job, reverse that number, please, James.
Reverse 594?
Yeah, and we're going to add these together. So
495.
I think I agree. And we need to add these together. This is going to be the page number you're going to find from the book. I'm a little worried, actually.
I'm going to add them together. Okay, 4 and a 5 is a 9.
Yeah, I agree.
9 and a 9 is 18.
I wrote the 1 down the bottom.
8
is that right?
and a 1 down there, carry a 1. Okay. 5 and a 4 and a carried 1 is 10. 1089.
1089. I'm more worried than I should be. Can you find page 1089?
1089? No,
It's all right,
sorry.
James.
Sorry, no,
I've
there's
memorized the book. I know. I know.
There's 400 pages in
I
here.
know there are. I don't know what. Oh, thanks for your number. It's a great number. I want to use it still, even if it's too big. We've got over 100 pages, yeah?
We've got, yes, 400 and something.
Okay.
Yeah.
Well, let's do the first 3 digits. Can you find page 108? Don't say anything.
Page
In fact, I was going to do the first word on the page you picked, but I think I can do this. I've got the 9 left.
Page 108. Okay, let me find it.
Remember, this book is a little bit weird. The pages run backwards. Matt, I don't know what he was thinking. I know what he was thinking. He was thinking, I want to be clever with the page numbering. So the page 108, unlike most books, will probably, because it's an even page, normally on the left, this time it will be on the right. Don't say anything. Can you find the 9th word? I was going to do the first word. We've got a 9 left over. Can you just count the 9th word? Don't show the camera yet. Are you looking at it?
I've got it.
Can you focus on that word? Just, maybe look at the camera. I'm not looking in the reflection of your eyes, but your eyes are circles, and that's appropriate because the word is arcs.
Oh my! Is
that correct?
It is.
Do you want to just check on the camera here?
Can we see it? Arcs. Absolutely was.
Instead of using blah blah blah, hold on. Instead of using bars of circles as the arcs, we're using sectors of spheres. Sections of spheres. Yeah, it's arcs. Amazing. So it's a good book. I've memorized the entire book, and that's clearly proved it.
You have. I mean, I'm amazed. So are you telling people that to do a magic trick, we should memorize books?
Well, certainly, it is quite an impressive thing if you can appear to have memorized the book. And this is, again, the art of magic is to do something which everybody knows is blatantly impossible. Or at least extremely hard, and yet apparently pull it off. And so obviously this trick done on video is a bit of a confusing, like, well, they've just prearranged this. That's something we've got to acknowledge the elephant in the room. A trick on video is very rarely as effective as live. But the fact is, I will do this trick live with the book I've just been handed. And that is fun as a piece of performance, and it's fun as a piece of mathematics. So if you wanted at home to watch a video and go and investigate this, the investigation is how on earth would it be possible to do that trick live with the book that I just only held for a few minutes, perhaps, because it is possible.
Are you going to give us any hints about how this worked?
Well, like we mentioned in other contexts, maths and magic tricks go together in that they provoke conjectures. That's the mathematician's word for it, but like in a magic, you have an idea. The idea being, in this case, I could see how that might work if the answer was always the same. If the answer is always 1089, then we'd have a way of doing this trick, perhaps, and the rest of it is packaging. But that's something to investigate. You have a conjecture, you test it. Can you find any numbers that break it? And yes, there are numbers that break this, but let me spoil at least part of the surprise. Most of the time, if you pick a 3-digit number, reverse subtract, reverse add, you will get 1089. And you can go and check if you wish. My advice is pick numbers that are not palindromes. They don't have the same forwards and backwards. If James had picked 666 and reversed it, we'd have got to 0, and it wouldn't have been a very interesting story for the rest of the time. And there are some other problems as well if you have numbers which aren't very different. But I'll let people explain or explore with that if they want to. But there is an interesting piece of maths that still remains, which is if you have that conjecture, and it does look like it does generate 1089 a lot of the time, what we could do is check every 3-digit number. And we've got 3 hours left of today, so we should just crack on and check every 3-digit number.
There must be a better way.
Thank you, James. The mathematician in you rises to the challenge, and this is another example of what mathematicians do. They look for efficiency in explanations as well as being fundamentally lazy. There is a better way, and what we're going to do is prove that this always works. Is that okay?
Yeah,
I'm going to do this on the screen. Okay.
Let's do it.
So I'll leave the calculation there so we can see what's going on, but I'll leave it over on the side. What I am going to do now is write down every single 3-digit number ever, all of them on the screen. I've only got a bit of space, but I'm going to use this. And I know you're okay with this because you've met algebra before. So that is representing a 3-digit number for me. Unfortunately, algebra normally written like that wouldn't mean a 3-digit number. It would mean the number A times the number B times the number C. So I've got to do a tiny bit more work here. And the clue is actually your number over here, the 852. That 8 wasn't actually an 8. In the same way, this A is not actually just A. And I know you know this, but tell me, what is that 8 actually?
It's A times 100.
Yeah. So over there, that was 800. And so this is, in fact, 100 lots of whatever the digit A is. And that gives us a sort of way into this. We're trying to represent any three-digit number, ABC, in algebra. And we get to do that by realizing that the tens column has a 10 going on, and that's just units. And actually, if I add those together, that is a three-digit number in algebra. And that's sort of, I think, the hard part of this setup. Once you've got that, this is the power of algebra. And this is the reason why I like showing this trick, is that I've now got a general version of a three-digit number, and I can do this trick on all numbers at once. So that's what we're going to do. I'm going to take ABC and reverse it, in which case I get CBA. It would be 100C plus 10B plus A. Is that okay for you, James?
Yep.
And the first part of the trick is we subtract those two. So I'm going to put brackets around them and realize that I've got 100A. I need to take away 1A. I reckon that's 99 A's. 10B, take away 10B is just 0. That's okay, I hope. And I've got C, take away 100C. So that's negative 99 C's. And I'm going to do one more mathematical thing here and factorize this. Who knew that GCSE algebra was going to be useful for a magic trick? This is telling me, I'm only halfway through the trick, but this is telling me that at this point, I will get 99 times something. In more everyday language, I'll get a multiple of 99. And actually, not all of them. So I can start listing the multiples of 99. There's one of them. It's underneath my thumbnail. So let me just find a little bit of space that you can see. So I've got 99. That's a multiple of 99. I've got 198. And in fact, the pattern of 99 times table is really nice. I mean, nobody learns their 99 times table, but within sort of 2 seconds, you can start predicting what comes next. So they are the first 9 multiples of 99. And I'm going to stop there because I also know that A and C have limits, they're digits. So the biggest that can be is if that's 9 and that's 0, and then I get 9. And this one down here is 9 times 99. So if you have tried this trick at home, go and check what number you started with. You'll find that halfway through the trick, you will have got one of those numbers. In fact, if we check James's over here, we've got 594, which is in there. This is already predicting something powerful, but it's still not a great trick yet. What's nice is the pattern that most people spot is that there's always a 9 in the middle column. So this column down here, which I've just kind of crossed out, always has a 9. And the first and last digits have a nice thing about them. It's just a fluke of the 99 times table. The first and last digits always add to 9. It's just the way it works. Which means that if I grab any of these numbers, let's pick a different one from yours. Let's try 297. And I do the last bit of the trick, which is reverse it and add. You end up lining up 2 numbers, which will add to 9 every time. And the middle 2 will always add to 18. Carry the 1, add to 9, carry the 1, boom, 1089. Every time, drop the mic, or in this case, my pen. That's it. It's always going to work unless that bit is 0, in which case you get 99 times 0 and you won't make it onto this list. It's fun, and you know it's going to work because of the proof and the mathematics. But it's still fun. There's the psychology element of surprising people with that. So that when mathematics of certainty meets the psychology of human surprise, we've got a sign that there's a nice bit of maths happening.
And just before we go, do you have anything that you want to plug?
I've written this lovely book called Things to Make and Do. Oh no, that's Matt's. Have you still got it?
Sorry, I'll give that. Shall I give it back? I'll give it back.
Okay, yeah. Well, you've got to send it off the screen, otherwise I can't grab it. Okay. Got it. Thanks. The thing I should plug is that if you want to book me to come and do a talk at a school, whether you're a teacher or a student, then you can search my website, which is dispensparks.co.uk, and watch Numberphile if you like interesting bits of maths. Numberphile's full of bits of maths that people have found curious enough to talk to Brady about making a video. And if I write a book, then I suggest you buy it.
Thanks to Ben for bringing in the 1089 trick. I hope you enjoyed it, and I hope you try it out for yourselves. I'll put a link to Ben's website and his Twitter in the description. And I guess that's all from me for now. So I'll say until next time, stay curious.